続きまして、ティム・ブレイさんによる The World in 30 Minutes です。それではティムさんよろしくお願いいたします。
Hello, my name is Tim Bray. I work for Sun Microsystems. I'm an old man with a white beard, and I've been programming computers for pay since 1979. And I've been working mostly with text since 1987. And I've been working with Ruby since 2006. And Ruby is my favorite computer language. I think it... And I want to see Ruby succeed and become more popular because I think that by learning Ruby, programmers become better programmers, and programs become better programs. So we should look at the areas where we can make Ruby more popular and more successful. So the problem we have to solve is quite simple. This is from 1 year ago, and it shows the languages that are used in blog posts. Now, this is 1 year ago. The figures are not so exact, but the message is very clear. The internet is not English only. It's not Japanese only. It's not French only. It is for everybody in the world. And the problem we are trying to solve is easy to understand. We want to make Ruby useful for everybody in that picture. Well, we have to start by not doing that. There are many, many Perl programs with this in them. And every time you write that, you have made a mistake. It was, this quotation is from Larry Wall, the author of Perl. So if we want to prepare our language, Ruby, to process all the languages of the world, we have to solve a few problems. First of all, we have to agree what characters are possible and what we know about the characters. Then we have to agree how we take these characters and store them in memory on disk, how to store them electronically. Then we have to agree how to label them, and that is a hard problem because on the internet anybody can send you anything. And then finally, we need good APIs. We need good interfaces to allow programmers to make use of characters from around the world. Now, the first step is to understand the writing systems of the world. If you want to do that, I recommend this book, which is a very beautiful, very expensive, very large book. It has 74 sections, and in each section is several writing systems. And the study of writing systems is a very large, very complex subject. And fortunately, you don't have to understand all of that. If you want to understand how to process text on the internet, they gave me a Wii. You should look at this document. It is very easy to find with Google. It describes the best practices for interchanging text on the internet. It is quite Unicode oriented, but even outside of Unicode, the issues and practices it describes are very useful. So I mentioned Unicode, And Unicode is really, really important. Unicode is the result of a very large amount of work by a very large number of people. There are two things. There is Unicode and there is the ISO standard 10646, but they are identical and they will remain identical. If you are interested, this book you can buy off the web. It's pretty big and pretty expensive, but it's very, very well organized, very, very well printed. It's a very beautiful book. If you want to understand text processing, I recommend it very strongly. So I will spend a couple of minutes talking about the inside of Unicode. What is inside Unicode? It is very easy to spend days talking about this, but we will discuss it very briefly. So Unicode identifies that many characters. They are organized into 17 groups of 64K. Why 17? Long story. I won't tell that story. So most of the groups are empty. Almost all the characters that you will want to use are in the first group. And they are called the basic multilingual plane. There are some other groups that are not so much used. The syntax for referring to a Unicode character is like this: U plus, and then 4 hexadecimal digits, or up to 5 hexadecimal digits, that describe the number of the character. So characters are identified by number. So most of the interesting characters are in here. So let's look inside there. And it goes around the world from west to east, basically. So all of the languages that have alphabets are at the beginning. So Romaji, Roman characters, Greek, Russian, Arabic, Hebrew, etc. Some of the Indian languages. There is some punctuation. You have some other extra Asian language materials, so hiragana and katakana, and things like that will be here. Then there is a very large number of Han characters. There is a big space for the Korean, Hangul, and some extra stuff out here. In Unicode version 5, there were 27,000 Han characters and 11,000 Korean Hangul. Now, so the Unicode comes with characters identified by number, and then for each character in the database, there is a lot of information. This is what you find in the Unicode database, and this is the English explanation. The Unicode database is available on the web. It is very useful. The Rails code, active support multibyte, actually reads these tables and uses them. Now, one interesting problem, this character, which is an E with a capital E with an accent grave on it, there are 2 possible ways to encode it. So there is one Unicode character for E with accent grave, or it's possible to have the capital E followed by the accent grave character. And this is one of the big, big problems in Unicode. So I have a small slideshow for you, just to give you a picture of some of the characters that are available in Unicode from all around the world: Greek, Russian, Hebrew, Arabic, somewhere in India, somewhere else in India, Thai, Tibetan, very beautiful, eh? Cherokee, American Indian, Canadian Indian, Mongolian, per mil, useful fractions, arrows, math, love, hiragana, katakana, kanji, lots of kanji. Hangul. Now this is from outside the basic multilingual plane, those last two. They are some of the characters that did not fit in. So, is Unicode perfect? No. But there are many things in Unicode that are really quite good. To start with, there are many, many, many characters there, and it's mostly empty. So all of the human characters seem to occupy about 10% of Unicode. So when we go exploring into space, you know, we have room to meet 2 or 3 species of aliens before Unicode will be filled. There is private use areas. So if you have private characters, you can put them in Unicode, and Docomo is using these for emoji. So they are using the private use areas for those. The process of discovering new characters and putting them in is quite reasonable. I have worked with this over the years, and if you discover problems, you can talk to these people, and they are quite welcoming. The Unicode database is very good, and the other thing is that there is very good support for Unicode in many, many computer languages and databases. The European legislation, the law in Europe, requires Unicode. The IETF, Internet Engineering Task Force, and the W3C, a Worldwide Web Consortium, require that when Internet protocols exchange text, they must use Unicode. So, if you want your computer language to implement the specifications of the Internet, you must have Unicode support. Unicode is not perfect. There are a few problems. One I already talked about, the combining forms. It is possible to have multiple different encodings of the same character. This is irritating for programmers, but it is not fatal. When they built Unicode, they included ASCII and Iso-Latin and the Russian alphabets and Shift-JIS and Big Five from China. They included the characters from all the previous character encodings. And this was difficult, and there were collisions, and there was politics. So there are some issues in there. And the third issue that is controversial about Unicode is Han unification. As we all know, the usage of Han characters, kanji, is somewhat different in Chinese and Korean and Japanese. But they decided for Unicode to unify them. And this was quite controversial. Here are some URLs that discuss this problem. The Wikipedia article is quite pro-Han unification, quite positive. The TronWeb article is quite anti-Han unification. This URL here has really a very, very good discussion. Now, one area that Han unification did not address was the very, very large number of old kanji, historical kanji, from religious texts, from historical texts. And these are not in Unicode, and probably will take a long time to come into Unicode. So there are some alternatives, such as Tron, GT Code. Mojikyo last time I looked, it has over 140,000 characters. So that includes more characters than all of Unicode. So first of all, the first problem I mentioned is we have to agree on what the characters are. Well, if you want to participate in the internet, that choice is made. The characters are Unicode characters. The next choice is how do you take the characters and store them in the computer? For example, this character, its hexadecimal value is 4E2D. Well, are you going to store this in memory little endian or big endian? Variable length encoding or fixed length encoding? There are many different ways to store this integer in computer memory. I could easily talk for a couple of hours about the different ways of doing this and the options, but I'll just mention them briefly. Of course, before Unicode, each country had its own way of storing computer text, and of course, Apple had one way, Microsoft had one way, Unix had one way. So I'm sure we've all seen these things, ASCII, EBCDIC, ShiftGIS, EUC, Big Five, many, 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 many of these things. And these are still used. For example, it is legal to have XML documents in ShiftGIS or EUC or something like that. But for portability, it is better to use the official Unicode formats for storing characters. The only ones that are really used are UTF-8 and UTF-16 for interchange. If we look at the Unicode issues, I'm not going to read this slide. We will post the slide on the web. You can read it all. The trade-offs, the advantages and disadvantages of the different formats are quite complex. For C programming, UTF-8 is much friendlier. For Java and C#, UTF-16. UTF-32 is WHRT when you're programming in C. I don't think Ruby programmers should have to worry about this. I think Ruby should take care of this so that Ruby programmers think only about characters. How are we going to achieve that? Well, there's a bunch of problems you have to solve. The biggest problem is that we exchange text on the internet, and when you have some bits that come in a message on the internet, you have to decide how they are encoded. And in general, this is an impossible problem. So if you, before I leave this slide, I should say, I wrote a very long article on this subject. So if you search for characters versus bytes, you can read all about this. But the big problem is that you have some bits that come in over the internet, and you want to put them through the machinery, and you want to turn them into beautiful characters. And in general, the problem is impossible. So there are some approaches. You can guess. This is what web browsers do. Internet Explorer, Mozilla, Netscape, IE, Firefox, Safari. They look at the bytes that come in and they think, oh, is this ShiftGIS? Maybe. Is this UTF-8? Maybe. It's not really very good, especially for business to business. You don't want them to be guessing. Now, on the the other approach is that when you receive a message on the web, you get headers, HTTP headers. And one of the very useful HTTP headers is content type, which gives you the media type, and it should tell you what the encoding of the characters are. So the official rules of the internet, written by the IETF, say you must use the headers. Unfortunately, sometimes they are wrong. It's a fact of life. So there is, however, one good solution to this, and that is to exchange XML. Because XML is self-encoding. An XML parser can read the first few bytes of an XML message and with 100% confidence discover the encoding. So when you are interchanging messages on the internet, this is a big advantage of XML. So that's the second problem. How do you transfer between characters and bytes? That leaves the third problem. What are the right APIs and interfaces? Well, different languages have different approaches. Java uses UTF-16, so that causes some problems. There are the string data type and the byte buffer data type are different. They don't have any special syntax for regular expressions, which is very irritating. But the implementation is quite good. Java string processing is really quite fast and quite reliable. Perl 5 has Unicode support, but it's buggy and quite difficult to use. But that's okay, because Perl 6 will solve the problem. Python, in Python 3000, is making a big change. I think this is very good. I think the way Python 3000 is approaching the problem is very well thought out. Let's talk about Ruby. So here are some methods on string, and these are the methods that have potentially big problems with internationalization. For example, if I test two strings for equality, how about combining forms? E accent as one character or as two characters? Tricky problem. The square brackets and length, do you want to know about the number of characters or do you want to know about the number of bytes? In my opinion, programmers don't care about bytes. They want to know the number of characters. Similarly, problems for things like index and rindex and size and slice. There is ambiguity about number of bytes versus number of characters. Oh, okay. I think that in many problems, it would be very convenient to process text one character at a time. Ruby doesn't make this very easy. In active support multibyte, they have a chars accessor for strings, which works very well. Unfortunately, it does not work on Ruby without Rails. And I think that's a problem. Another big problem is case folding, upper, lower case. In the general case, it's impossible, because the mapping from upper to lower case depends on where you are. And the result is that in Java, for example, Java has a method called string.toLowerCase, and it's incredibly slow because it tries to do all that stuff. So just don't do it. Upper and lowercase mapping should only be done for ASCII. Another problem we have is with regular expressions. In Perl, I can do things like this. That's a letter, that's a number. Oniguruma version 5 can do this, but Ruby is now using Oniguruma version 4. Even in Yarv is at the moment Oniguruma version 4, and so Oniguruma or Yarv can't do that. That's a big problem. Another problem is that programmers very much like the idea that a character can be identified by a number. You know, a character has a particular number. So this means euro. This means yen. Dollar is just dollar. So this is a very, very convenient idiom for programmers, and Ruby should support it. Well, programmers these days, in particular Java programmers, the Java programmers that we want to attract to Ruby, have come to expect Unicode. They have come to depend on Unicode. They want Unicode that is efficient and correct and robust. And if you give them a language that does not process Unicode, they may say that you are a racist. I'm serious. We've seen this happening. Sometimes people who work with historical texts and religious texts have to work outside Unicode, but for business, Unicode is the right answer. So, what are we doing? So, multilingualization, M17N, that is going to solve it, we hear. I'm waiting to see it. Active support multibyte is in Edge Rails. Nikolai has a character encodings project. JRuby, of course, is working in Java, which is a 100% Unicode environment. So the bad news is that this is a big, complicated, ugly problem. The good news is that a lot of very smart people are working on it. Thank you.
ありがとうございました。それでは質疑応答に移りたいと思います。質問ある方は手を挙げて、知らせてください。日本語でも大丈夫です。どなたかいらっしゃいませんか？あ、いらっしゃいましたね。ではそちらの、真ん中の白い服の方。
松永と言います。確か以前松本さんはRuby の将来のバージョンでは特定の、文字列エンコーディングにこだわらずに複数の文字列エンコーディングを同等に扱えるという方向を目指すというふうなことをおっしゃってたと思うんですけれども、ティムさんはむしろユニコードをメインにハンドリングしていくべきだというふうにお考えでしょうか。
Yes.
Thank you.
Hi.
他に何か質問ある方いらっしゃいますか？前の方の黒い T シャツの方。
すみません、木村と申します。ユニコードのキャラクターを表すのにその名前を使って表すという手法がありますけれども、例えばこれをその正規表現を備えている言語を全部で共通にするとか、揃えることをすべきかどうかということに関してどうお考えですか？ちょっと待ってください。すみません。もう一度共通の記法を言語を各言語で持つべきかどうかということをどう考えているかと。例えば Ruby と Python と Perl で同じような書き方でそれるべきじゃないかとか。
文字識別 種別
そうです。例えばバックスラッシュの P のブレースとかなんとか。
正規表現の方。
まあ正規表現でもどうでもいいですか。はい。
Both for regular expressions and for identifying characters from different languages try to use the same.
I don't think that's so important. In the area of regular expressions, it seems that everybody is using PCRE, you know, Perl compatible regular expressions, so why not? It's good enough. The languages have different syntaxes. You know, Ruby looks different from Python. Python looks different from Java. That's okay. You know, having your own syntax for referring to characters is okay, but the characters should be the same characters, and in most cases, they should be Unicode characters.
Thank you.
まだ質問もう一方だけ。じゃあ、前列の方。
田中です。合成文字は正しく1文字として扱われるべきだと思いますか？
So this is the problem. The name for this problem is the normalization problem. Okay, and there are several different. Oh, it will come. It will come. Somebody say I'll put it up after. There are several different approaches. One approach is to use as much combination as possible, and the other main approach is to use as much separation as possible. The World Wide Web Consortium, in that document that I pointed to, the character model for the World Wide Web, has very specific recommendations for normalization form, and they recommend the form with the maximum compression. So you would do that as one character, not two characters. They also recommend very strongly that when you are sending a text on the internet, you should normalize before you send, so that when you send a message, it's always in the normalized form.
But some characters have no composed form.
True. So normalize, compose when possible.
それでは時間となりましたので、質疑応答打ち切らせていただきます。ティムさん、ありがとうございました。